Okay, we've seen some Python exceptions and how they look like, but given the fact that an exception interrupts the normal execution of Python code, it would be more convenient for us to handle an exception when it occurs and tell Python to keep executing the rest of the lines of code in the program. To do this, we will use the so-called try-except block for exception handling. Let's consider the zero division exception from the previous lecture and see how can we handle it properly. First, let's define the try and except clauses. In the try clause, you insert the code that you think might generate an exception at a given point. Of course, this code will have one level of indentation from the try statement itself. As with for or while or if statements, you must always type a colon after the try keyword. Then you have to input the piece of code you want to execute. So let's do this inside the Python interpreter. We will use the same old for loop from the previous examples. So for I in range of 10, colon. Then at the first level of indentation, try, colon. Sorry, enter. Then at the second level of indentation, let's try print I divided by 0. Okay, up to this point, you should notice a couple of things. First, as I said, the indentation. The try statement is indented by one level to the right from the for statement. After try, a colon should always be inserted. Then the code we want to check for exceptions will be also indented one level from the try statement level to tell Python that the following code belongs to the try block. In this case, we are 100% positive we are going to get an exception. Now let's move to the second part, the except block. Below except, we will specify what exception types Python should expect as a consequence of running the code inside the try block. You should think of this whole try except procedure as you are telling Python the following. Try to execute the indented code below. If no exceptions occur while executing it, then skip the except block and move on to the rest of the program. If an exception does occur and it is defined in the except statement, then execute the indented code below that except statement. So, in our case, knowing that division by 0 is not allowed, we are expecting a zero division exception. Now let's tell Python what it should expect. So, for I in range 10, try to print I divided by 0. Now at the same level of indentation with try, we type except and, the name of the exception we are expecting. So let's say zero division error. Then a colon and one level of indentation to the right. Let's say print division by 0 is not allowed. And that's it. Okay, so let's analyze the result. Python took each element from the list generated by the range function, tried to divide it by 0 inside the try block, realized that this isn't possible, so it raised the zero division exception in the background. Now, because we had that exact exception defined and treated by the except clause, it didn't generate the same old output like we had up here, but instead it executed the code within the except block. If we would not have the zero division exception specified in the except clause, or if we would have any other exception defined instead, Python would give us the classic exception output like we saw in the previous try. Now let's test this. Let's say that we didn't realize that a zero division exception may be generated by our code, but instead we wanted to cover any name exception which could have occurred. So we defined this in the except clause. Let's use the up arrow key for I in range 10. Try to print I divided by 0. Then except, and instead of zero division error, let's say we have name error. Enter, and let's say print you have a name error. As you can see, this time Python returned the old exception output. Another thing I want to clarify is that if the code inside the try block does not generate any exceptions, then Python doesn't even look at the except clause and moves on to the rest of the program if you indeed have further lines of code in your program. To do this, I am going to change the denominator in division operation to be 1 in order for the operation to be allowed. So for I in range 10, try, print I divided this time by 1. Let's use the old except 0 division error. Now let's print something here. Let's say 0 division is just wrong. And then a print statement at the same level of indentation with the try and except blocks. Print, let's say, the rest of the code. Okay, I have also added the print the rest of the code statement in the for loop at the same level with the try and except blocks, just to show you that for each iteration, Python tries to execute the I divided by 1 operation. It succeeds without any exceptions, skips the except block, and then executes the rest of the code without even caring that except is there. Pretty rude, but that is the way Python does it. Another thing to add here is that you can have multiple except clauses after a try block. This enables you to be super cautious and handle multiple types of exceptions that can be raised by the try block. So let's see this. Let's use for I in range 10, try. Let's use print I divided by 1. And now let's define multiple exceptions. So except, let's say 0 division error. Here we will print not allowed. Okay, let's try to catch other exceptions as well, except name error. Print, you have a name error. Let's also add another one. Let's say except value error. This is another kind of exception in Python. Let's print wrong value or something like this. Okay, now you may ask me, okay, but what if I want to catch all possible exceptions that can be generated by my code inside the try block? Well, you can just use the except clause alone without specifying an exception name to be expected. Something like this. Let's say try, print I divided by 0, except, and that's it, colon, and let's say print exception was raised. Okay, this is however not recommended, and it is not a good practice because it will catch absolutely all programming exceptions which may occur and hide the actual root cause of an exception. I strongly recommend that you create multiple except clauses if you need them and specify the exception name each time. Finally, two more things about try except blocks. You can add two other clauses after the except clause or clauses. They are called else and finally. The code inside an else clause is executed if the code inside the try block raises no exceptions. So let's try this. Let's say try print 4 divided by 2 except name error. Sorry, let's type this again. So try print, okay, except name error, print name error. Okay, now let's insert an else clause. So else colon, let's say print no exceptions raised by the try block. Now the code inside a finally clause is executed whether the code inside the try block raises an exception or not. So anything you type inside the finally clause will be executed regardless of an error or exception was raised or not. So let's try this. Try colon print 4 divided by 2. Let's say except 0 division error, print not allowed. Okay, and now let's add the finally clause. So finally, then a colon, and then print, let's say I don't care if an exception was raised or not. Okay, so as expected, we got the code executed by the try block, and the print statement executed, the print inside the finally close, which, as I said, is executed no matter if any exceptions were raised. Now, using code that will generate an exception in the try block, let's try this also. So let's use try, print, this time print 4 divided by 0, the except clause, and finally the finally close. So finally, I don't care if an exception was raised or not. Okay, as expected, we got the print statement executed inside the except block, not allowed because we indeed had a division by 0 this time. And in the end, the finally clause was also executed because it doesn't care if an exception is raised or not. Okay, that's almost all you need to know about exceptions and exception handling for your future networking tasks.